My career development path has always involved technology. I've always been interested in computer science and programming and other things. I was one of those kids of the 80s that got their first computer when they were in 6th grade, that new generation where computers were cheap. And I was programming all throughout junior high and into high school, not necessarily with infectious disease on my mind. I had a vision that I wanted to be a video game programmer like most kids. As I got into college and started my track along biochemistry and so on, I found that those tools were incredibly useful. And to be able to be involved in different technology development aspects, such as computer programming, and then later on building my own things, I was able to give me an advantage over folks that perhaps weren't involved in those things. That is, I didn't have to rely on somebody else to get a particular piece of data generated because I could make the thing that generated that data. During my graduate education, I found that given the freedom in the environment to innovate and develop new technologies was really important and really critical to my own development. And so when I came here to UCSF, I was actually given the option of setting up a large open space for the explicit purpose of innovation and development of technologies. And so we named it the Center for Advanced Technology, the CAT. And what it is, it's more like a do-it-yourself maker's fair where people can come in, innovate, play on new technologies and so on. And we solicit companies and individuals to bring in the latest and newest gadgets, newest technologies, so that students, postdocs, and faculty can freely play 24/7, no bars, no restrictions. We encourage people to take apart the instruments. Now, that often means that things are going to break, and that's okay. That's part of the game. So one of the most exciting things in the near future that technology is bringing us is this amazing resolution with which we can look into our own sequences. And so this deep sequencing technology, the ability to sequence everything that's in a given sample, is going to bring, eventually, I believe, a whole new set of biometrics. We already know you can get genetic tests. Now, not many of those things you can test for actually have any consequence on your life in terms of making health decisions. But there will be a time, I believe, in the near future where you're not only going to have your whole genome sequence, but you could get periodic or semi-updated sequences that tell you about all the infectious diseases that you have too, and then maybe you could tailor those or manipulate those to maximal benefit. That also goes true with the microbiome and all the resident gut bacteria that we live with and so on. We're now coming to realize have influences over our physiology and our health. And if you can measure it, that gives you an avenue to manipulate it and engineer it for the maximal benefit. That's where I think all this is going. One thing that's particularly fascinating to me about viruses is that they're exquisitely evolved molecular machines. And one of their finest evolutionary qualities is their ability to mutate themselves. They deliberately make errors. They're evolved to make mistakes. And these mistakes give them an evolutionary flexibility that is unprecedented. For example, you've always heard about why don't we have a medication for the common cold? There was a major drug effort a while back to create a drug for the common cold. When a drug was finally developed that blocked infection by the common cold, a rhinovirus, and was tested in people, it was found that the virus was able to evolve so-called escape mutants, viruses that were able to get away from the drug within the first 24 hours. And therefore, symptoms due to the virus were reduced only by about a day, making the drug worthless. And this is the real challenge in RNA viruses and in vaccines and so on. How can you possibly stop a virus which has the most exquisite capability of evolving every time, every second? It is important to lead a balanced life. And I have a family, and it's been a wonderfully fulfilling thing. And I divide my time as equally as I can between my family life and my science life. And I try to bring that balance to all the different things that I do. And it's difficult. There's no magic recipe for how you balance those two different things, because on one hand, if you're doing science full-time, you wish you were spending more time with your kids. You're spending time with your kids, you know that there's scientific problems that need solving, and they're not getting done when you're at Disneyland. But it's important to balance those two things so that you feel that you are doing the best you can in both worlds.